Welcome to the Smart Bite Science and Tech channel.
Great to be here.
Today, we're doing a deep dive into something really fundamental for AI's future.
Absolutely. We're talking about understanding how these incredibly powerful systems actually, well, work.
Exactly. You see the headlines, right? AI doing amazing things, writing code, incredible images.
Stuff that feels almost magical sometimes.
But have you ever really stopped and thought, how does it do that? I mean, really, how?
And the truth is, even the experts, the people building these things, are still figuring out a lot of the details. It's a huge area of research.
It really is. It reminds me of something Dario Amodei highlighted, this idea that figuring out the inside of AI, interpretability, they call it.
All right, interpretability.
It's not just, interesting academically.
No.
He argues it's becoming a real necessity.
Definitely. Think of it like having a super complex machine, one that's getting more powerful all the time.
Yeah.
Wouldn't you want to know what's actually happening under the hood? Especially if that machine starts influencing more and more of our world?
You absolutely would. It's like traditional software feels different, right?
Totally different. If a character in a game says something specific.
You know a programmer wrote that line. There's a clear instruction.
Precisely. But with generative AI, when it writes, say, a really good summary, the exact steps, the logic it followed, it's often, well, it's opaque.
Opaque, that's a good word. And some researchers use that analogy, don't they? That AI is grown more than built.
Yeah, I like that analogy. It captures something important.
So let's unpack that a bit. Grown versus built.
Yeah.
What does that really imply here?
It's like planting a seed. You set up the conditions, the soil, the water, the light.
The training data, the architecture.
Exactly. But the final plant, its exact shape, every leaf. You didn't explicitly program each part. It develops based on those initial conditions and its environment.
So inside these AI models, you've got these vast networks.
Yeah.
Numbers, connections.
Billions, sometimes trillions of parameters.
And somehow, they learn to do these incredibly complex things. But the step-by-step mechanics of how they connect input A to output B in a meaningful way, that's the mystery we're trying to solve.
And that mystery, that lack of a clear internal view, it connects directly to a lot of the anxieties around AI right now.
Such as?
Well, the big one is unexpected behavior. The worry that an AI might do something harmful or biased or just weird.
Something the creators didn't intend or foresee.
Exactly. Because if you can't fully see the internal logic, how can you guarantee it won't develop some unintended capability or goal? Predicting and preventing that becomes much harder.
Okay, so this opacity, not being able to see inside clearly, it creates risks. What kind of risks are researchers most focused on?
Well, there's the misuse potential, the concern that someone could leverage AI, maybe even unintentionally guide it, towards creating dangerous things.
Things we definitely don't want AI helping with.
Right. We put safeguards in place now, of course, trying to block harmful outputs.
But it often feels reactive, doesn't it? Like we're plugging holes after we find them.
It can be. If we truly understood the internal mechanisms, maybe we could identify potentially dangerous lines of reasoning or capabilities within the model itself, proactively, before they even surface.
So this isn't just some abstract scientific puzzle then. It has immediate real-world consequences.
Oh, absolutely. This interpretability issue directly impacts where we feel comfortable deploying AI today.
Right, like in really critical areas.
Think about high-stakes domains, finance maybe, or controlling essential infrastructure, or even healthcare diagnostics.
You need to trust its reasoning, not just its answer.
Precisely. And in some fields, like, say, mortgage lending, explainability isn't just nice to have, it can be a legal requirement.
And current AI often struggles with that.
It really does. Imagine an AI spots a rare disease pattern on a scan, maybe with amazing accuracy, 99%.
Okay.
But if the doctors ask why it thinks that, and the AI essentially says, because the numbers told me so.
You can't really trust it, can you?
Right.
Or learn from it, or verify it independently. It's just a black box recommendation.
Exactly, that's the core problem. And this black box challenge, it's not brand new, is it? People have been trying to peek inside for a while.
Yeah, there's a history there.
Definitely. There's pioneering work in what's called mechanistic interpretability.
Mechanistic interpretability.
Which is basically the systematic effort to understand what individual components, like neurons or groups of neurons, are actually doing inside the network.
Like trying to map out the functions of different parts.
Yeah, they had some early successes, especially with vision models, right? identifying bits that seem to respond to specific things.
Like edges in a picture or certain textures or maybe simple shapes.
Exactly. Things that made intuitive sense to us.
Okay, but what happened when they tried applying those same techniques to the big language models, the ones driving things like ChatGPT?
Well, that's where it got really interesting and much more complicated. They found some components that did seem understandable, yes, but they also ran smack into this phenomenon called superposition.
Superposition? Sounds complex.
It basically means that a single component, like one artificial neuron, isn't just responsible for one clear concept, like cat ears.
Okay.
It might be involved in representing cat ears and maybe the color blue and perhaps positive sentiment all at the same time, overlapping.
Wow, okay, so one piece is doing multiple, seemingly unrelated jobs.
Exactly. It's like the AI is packing information incredibly densely, but it makes trying to assign one simple meaning to each part, well, really, really difficult. Almost impossible sometimes.
That sounds incredibly messy. Like trying to untangle a giant knotted ball of yarn where every strand is connected to dozens of others.
That's a pretty good analogy, actually. So, faced with that mess, how do you even begin?
Yeah, what's the approach?
Researchers have developed some pretty clever techniques. One key idea is using something called sparse autoencoders.
Spark autoencoders.
You can think of it very roughly, like trying to find the faint, meaningful signals in really noisy radio static.
Okay, filtering out the noise to get the actual message.
Sort of. The autoencoder tries to represent the AI's internal activity using a much smaller set of active components for any given input. It forces the system to find these more fundamental underlying concepts.
And does that help break through the superposition problem?
It seems to. By looking at combinations of these tangled neuron activations, they can identify patterns that represent clearer, more distinct, human understandable concepts. They often call these features.
Features, like detecting irony or identifying mentions of coding languages?
Potentially, yes. Things at that level of abstraction. And they've found millions of these potential features in some of the big models.
Millions. That's incredible. And it feels a bit like using AI to understand AI.
That's exactly where it's heading. The next step is what they call auto-interpretability.
Auto-interpretability, using AI to interpret itself.
Right. Using AI tools, often language models themselves, to analyze these millions of discovered features and try to generate natural language descriptions of what each feature seems to represent.
So, translating the AI's internal language into ours.
That's the goal. And beyond just individual features, they're looking for circuits.
Circuits, like in electronics.
Kind of analogous, yeah.
Yeah.
Groups of these features that seem to work together in sequence to perform specific steps in the model's thinking process.
So how it goes from an input through various feature activations to an output,
Yeah.
like a pathway.
Exactly. Imagine a circuit for, say, detecting politeness in a customer service request. It might involve features related to specific keywords, sentence structure, maybe sentiment, all working together.
It really does start to sound like developing that AI MRI that Amodei mentioned.
That's the vision, yes. The long-term goal is to build the capability to do a comprehensive scan and analysis of these advanced AI models.
A diagnostic tool.
A diagnostic tool, exactly. One that could identify a whole range of potential issues, biases, unintended capabilities, security vulnerabilities, alongside the other safety techniques we already use.
So, thinking about the listener here, what does all this mean for you? Well, AI is becoming more and more integrated into everything, isn't it?
It really is. From the apps on our phones to potentially soon much more critical systems.
So the ability for researchers to actually understand what's going on inside and to spot and fix problems before they become major issues, that seems crucial.
Absolutely vital. Developing these interpretability tools, these AI MRIs, could unlock much safer, more reliable AI.
Making it suitable for those high-stakes applications we talked about, where trust and being able to explain why are just non-negotiable.
And it could also be our best bet for tackling those worries about unintended consequences or potential misuse we discussed earlier.
It really feels like a race, though. Trying to develop these understanding tools quickly enough before the AI systems themselves become even more complex, maybe even completely opaque to us.
There is a sense of urgency, yeah. It's not about putting the brakes on AI progress, though.
No, it's about steering it.
Exactly. Steering it responsibly, making sure we understand what we're building as it becomes more powerful.
So as you listen to this, what stands out to you most about this challenge of understanding AI? What questions does it raise for you about where this technology is headed and how it might impact us all?
It's definitely worth thinking about. We really encourage you to maybe look more into this idea of AI interpretability. It's going to be increasingly important in shaping our future with this technology.